Dig in. Thank you all for joining. We'll get started right on time because we've 1 minute late. Sorry, we've got a lot to pack in to the next 40 minutes. I'm Josh Mandel. I'm the lead architect for the Smart Health IT project, and I'm here with Dan Gottleib. We're going to give you a whirlwind tour of Smart, an app platform for building apps that plug into various kinds of health IT systems. Starting off with some background, talk about some of the technology that we use to solve this problem. And then dig into a set of demonstrations and examples that you can use to get started quickly on your own. We'll try to save at least 5 minutes at the end for questions. So I want to motivate this a little bit, briefly up front. So we sponsored a report using KLAS to run a survey across many different healthcare providers and provider organizations in 2017. And one of the consistent kinds of feedback that we heard from providers when we asked them about their experience running clinical apps at the point of care is really exemplified in this quote, which is, we had this great population health tool, but we couldn't get our EHR to interface with it, and we had to enter all the information by hand, and in the end, we had to give up because we just couldn't physically keep up with that process. And I think this is still pretty typical for integration scenarios today, where it's obvious to a user how two tools ought to work together, but making that happen from the development lifecycle and testing and deploying has made it too challenging to do this kind of integration in the real world. I should note that in the top right-hand corner, there's a URL for these slides if you want to follow along now or later. So here's really the core focus for the Smart Health IT project. We want to make it as easy as we can for a rich ecosystem of apps to be able to plug into many different kinds of clinical systems. And so when we say apps, broadly, we mean the kinds of tools that clinicians could use directly at the point of care, but also patient and researcher-facing services and tools as well. And when we talk about clinical systems, there's many ways to count. One way you could look at this is in the US, systems that have been certified for some component of the ONC's EHR certification program. There's been on the order of 1,000 of these systems. So there's a very large set of different vendors that produce products sort of in this category of health record systems. And as an app developer, if you had to go and build an integration for every one of those things, it would be an unmaintainable software development and maintenance process. So what we provide in the middle is a standards-based API, standards-based integration layer called SMART. That's actually an acronym. It stands for Substitutable Medical Applications and Reusable Technologies. We'll get into a little bit about that concept of substitutable. But here what we're saying is users should be able to pick the apps they want. And in order to make that happen for the developers, we need to provide a few key building blocks. One is UX integration. So how do we put the user experience of an app inside of the workflow that a clinician has day to day? How can we embed an app inside of the EHR so that it naturally knows about things like patient context? If I go to run a growth chart and I've already got a patient record open, the growth chart should know right away which patient I'm working with. It shouldn't have to ask the user to select that patient again. So that's an example of the kind of integration that we do. And then there's a couple of pieces on the security side. So for example, we need a clear way to let users sign into an app without forcing them to make a new account for each different app they want to use. And similarly, for authorization, we want to give apps access to just the data that they need without giving them access to a broader set of data or different kinds of resources that they don't require to do their job. And then finally, we need a clean way to communicate those clinical data. And of course, for that, we're using FHIR. So we'll talk about the standards that we use under the hood, but the big standards are OAuth and OpenID Connect on the security side, and FHIR on the clinical data side. And just to talk a little bit more about the value proposition here, for users, the key idea here is that they get a choice of which apps they want to use. So if I have an app that I like to use for medication management or for scheduling, I should be able to pick that app. And if a better one comes along next year, I should be able to get rid of the old one and swap a new one into its place. So that's the value proposition here for users, is it's much easier to install or try out new apps. And on the developer side, what it really gives you is a much lower barrier to entry. It changes the economics of developing an app so that if you can build something that works in one place and have the hope of shipping it to many different kinds of clinical provider organizations, suddenly it makes sense to invest in really a polished user experience, building out a tool or a set of capabilities that go beyond just what your local staff might be willing to tolerate. And similarly, these are kinds of apps that can run in systems from different vendors and in many different kinds of contexts. So there's some kinds of information where patients and clinicians both want to view the same kinds of data. You shouldn't have to start from scratch building a totally new kind of integration for each of those cases. So that's a little bit on the value proposition side. And The big vision here then is that EHR has become kind of a platform. They provide core services that many different kinds of apps and tools need, but which would be wasteful or duplicative to ask each app developer to build independently. So things like the management of users and patients, handling workflow and business logic and data persistence, being able to ensure that there's a clean way to do regulatory compliance and audit logging. All these kinds of things become core capabilities of an underlying platform, abstracted away so app developers don't need to work through all the details of every one, and apps can focus on the kind of core job where they actually provide value, relying on an underlying EHR or other clinical data system to provide these kinds of horizontal or platform features. I won't spend much time here going into what is FHIR, because we're all here for FHIR DevDays, but just as context, we rely on FHIR to communicate clinical data in the Smart on FHIR protocol. And the idea here is this is something that should be very easy for developers who are familiar with web APIs overall. Even if they don't have much healthcare-specific experience, this is something that should be easy for those developers to pick up and get started with. And there is quite a fair amount of complexity in working with these clinical data under the hood. It's unrealistic to think that a developer is going to be able to understand a meaningful sort of clinical job without grappling with some of that complexity. So you can't make it go away, but we can at least simplify the interface to the point where developers are focused on the domain problems that matter to them. They're not getting stuck in the syntax or the wire formats. So what I'd like to do is talk a little bit through some of these security features, beginning with the workflow by which you can launch an app from inside of an EHR. And in the Smart specification, we actually talk about two different ways to launch an app. One is, and it's the one we'll start with here, if you're inside of the EHR already and you want to launch an app from there. That's what we call an EHR app launch. The other way of launching an app is if you're starting outside of the EHR, maybe just from the home screen of your mobile phone, and you want to start by launching an app on that home screen. That's what we call a standalone launch. And they're very closely related, but we define two different use cases depending on whether you're starting from inside of an existing session or outside. And I'll walk you through the details of this at a high level so you can start to get a sense of how this flow works. And so on the left-hand side of the slide here, you'll see the interactions that have to do with the app itself. So let's take a growth chart as the example here. I'm inside the EHR, and I'm going to launch this growth chart app. And on your right, you'll see the interactions that have to do with the EHR side of things. And so you'll notice that this interaction starts from the EHR. There's an outward bound arrow at the top. And in a sequence diagram like this, time moves from top to bottom. So the first step is along the top, and we proceed back and forth. And so at a very high level, you'll see there's kind of a dance that goes on back and forth between the EHR and the app at launch time. And I'll take you through that dance just sort of step by step so you can see what's happening. When the user first clicks on a button or a link inside of the EHR to launch this app, that's an explicit action, generally speaking. They navigate to a certain screen inside of the EHR, or they say, I want to view the growth chart now. And the EHR opens up a browser context. It could be an embedded web browser that runs inside of like a fat Windows desktop client. It could be an inline frame inside of a web-based EHR. There are many technologies that can do this, but the important thing is the app doesn't know and it doesn't care. What the app knows is it's being launched in a browser context of some kind. And the EHR opens up what's called the app's launch URL, and you'll see this in an example in our demonstrations later. And it passes along a couple of key parameters, one of which is what we call a launch ID. And that's what ties this whole session together. At that point, the app now has control inside of this browser context, and it begins what's called the OAuth dance, or the OAuth process with this step here. It sends the user back to the EHR for a brief moment to complete an authorization process. And this might be totally transparent to the user. So typically when this happens inside of an EHR, the user doesn't see anything here. Their browser screen might flicker for a fraction of a second as they're sent back to the EHR to complete the authorization. But in the case of a patient-facing app, this is actually an opportunity for an interaction to make sure that the patient knows what's happening, knows that data are about to be shared with an app, and can agree or decline to continue in that process. So right here with this arrow, this is an opportunity for user interaction to review and approve the data sharing that's about to happen. And then if the data sharing is approved, we move along here to step 2, where the app is able to get an authentication token, an access token, I should say, that it can use to interact with the EHR. And that's really the point at which the authorization dance is over. The app has an access token, and now it can use this to make standard FHIR API calls, like a request for clinical data, maybe historical heights and weights in the case of a growth chart, or medications in the case of an app that's going to display a medication list. So I mentioned this idea of an approval. Maybe a patient wants to approve what data are going to be shared from a security perspective, and I want to say a few words about how that works. Each time an app launches, it asks for the set of data that it's going to need to do its job, and it asks for that data using a simple language that we call scopes in the OAuth parlance. So Smart defines a set of scopes that apps can ask for that define the permissions they need. For example, maybe an app needs access to a patient's immunization records in order to display a chart indicating when those immunizations have happened. And so in that case, what the app will ask for is something like what you see on the screen here, patient/immunization.read. And this breaks down into a few key parts. The first here, patient, means this is an app that's working on one patient at a time, and it doesn't need access to all the immunizations across the whole population of patients. It just needs immunizations for the one patient whose record is currently open. The word immunization here is the name of a FHIR resource, and apps that work with many different resources might ask for many different scopes in order to request all those data that it needs. And then finally, the permission that it wants is read, and we define read and write permissions. But in the case of a simple app that's just displaying information from the chart, read is good enough for what that app needs to do. So the app can construct a scope that looks like this. And in general, apps pass along a whole list of the scopes that they want. And then the server can approve, or the user can approve, access for those scopes. So just to give you a sense of how this plays out, in an app that's going to maybe display some patient lab results, this is an app that might want patient demographics to know a patient's gender and age, for example. So that's patient.read. And then it's going to want access to those historical observations, so that's observation.read. If you've got a more complex app that's pulling data from across the record, and maybe it needs to follow the entire set of resources because it wants access to a patient's whole record, it might ask for star.read, and that means all the data that a server has about this patient should be available. If you're doing an electronic prescribing app, maybe it needs medication order or medication request in the upcoming draft of FHIR.write. Or if you're doing a population health app, maybe you're not limiting yourself to one patient at a time. You want to get access to a clinician's entire panel. So that would be user/ instead of patient/, and then reading all the resources would be star.read. So that's a quick example of the kinds of scopes that we define. And an app requests those scopes each time it launches to be able to limit the access that it's requesting. And I will say that this language is fairly simplistic. So it allows apps to request data just segregated by FHIR resource type. And if you think about it, there are some real limitations here. For example, the observation resource in FHIR is used for many kinds of data. Lab tests, vital signs, social history. Observation is a pretty flexible tool. And in this language for scopes, it's all or nothing. You ask for observations, or you don't ask for observations. And so this implies that if you're building a growth chart app, you would actually be getting access that's broader than just heights and weights. It's all observations. This is kind of a known limitation of the system. There's always this trade-off between how much you can do in an interoperable fashion and how much you can do in a fine-grained system-specific way. So this is our first version, which we're publishing as a agreed-upon standard that's supported by many EHRs. And we'll get into that adoption point just now, which is to say we've worked closely with a group called Argonaut. You heard this in John Halemka's keynote if you were here this morning, working with a set of EHR vendors and clinical provider organizations to get some experience working with these specifications, putting support into production, improving the spec based on that experience. And so we've worked with many vendors. At this stage, there are several that put this technology into their production EHRs today. And we'll point out where some of those sandboxes live so you can give it a shot against each vendor's implementation. And just to give you a sense from the clinical provider organization, there's a couple ways that you could build support for these APIs. The easiest and most straightforward today is working with a vendor that supports these APIs natively. So if you've got a Cerner system or an Epic system or an Allscript system or some other vendors, then out of the box in today's versions, you can get support for these APIs, and that's very convenient. But at the same time, you might be working with a vendor that doesn't have support for these yet, or you need to go beyond the scope of what's built in today. And so Duke University was an early example at the medical center there of a health system building its own support for these APIs before their vendor had gotten there. And so this is a clinician experience working from Ricky Bloomfield and his team. They built out their own implementation of these APIs, and they were able to run apps inside of their Epic-based EHR very early in the scheme of things, back in 2015. So you can see this adoption happening from vendor initiatives, as well as from healthcare provider initiatives. And both of those things are happening in parallel. Now, from the developer perspective, we want to give you a sense of the tools that you can use to build and publish apps. But first, just a quick glance at what it means to publish an app. And we mean something very specific in the smart sense, is we have a public gallery where anyone can come and publish information about the apps and services that they've built. And this is an open resource where users can come and learn about what apps exist, and in many cases try those apps out on a set of test data right in the browser. The idea here is to be vendor and license neutral. If you're building an open source app that runs across EHRs, great. If you're building a licensed app where you pay per member per month and it only runs inside of Cerner's FHIR implementation, great. The idea here is any Smart on FHIR compatible app should be able to be published in our gallery, and we don't charge anything to list your apps or to browse. It's a utility that we make available for the public. And I'll do a very quick demonstration so you can get a sense of what the gallery is like. It's apps.smarthealthit.org is where the gallery lives. And Dan, that's a pretty good heads up for you that we're not actually online or that our website is down. Neither one of those is great, but let me just debug quickly to see which one of them is the case, because if we're not online, that's going to make Dan's demos a lot harder. I'm just going to disconnect from the Wi-Fi and reconnect to the Wi-Fi. Did somebody say the Wi-Fi is down? Oh, great. Well, I'll pretend that my turning this off and on is what fixed it. But as long as it's working at the end, we'll be in good shape. All right. Well, I was connected before. I'm connected now, but I'm not actually on the internet. I'll keep going. Well, let me do a quick survey for somebody in the room. Are you experiencing this as well, where you're connected to the Wi-Fi, but the internet's not working? Yeah, OK. Fine. Not just us. We'll keep going. Now it's working? This is not a fun game, guys. Come on. Wait, but it's working for you guys now? Oh, I have a typo. That's even better. SMAT. Yeah. That's, in Boston, we might say SMAT Health IT, but the R really should be there. OK. Between the typographical issues and the website, now we're in business. This is the gallery. On the left-hand side of the screen, you'll see some basic categorization. This is not a real tractable problem to categorize every health app in the world. And we don't try particularly, but we try to give some high-level categories so that developers have a sense of where to put what they're building. And you'll see, for example, there's a set of apps that are all about medications. And I'll give you a quick example of one of these, which is about doing translations. So this is from a company called Polyglot. They have been acquired by First Data Bank now, and they're actually a member of Smart's advisory committee, so we do receive funding from them in the interest of full disclosure. But they were one of the first apps to integrate with this platform, and that's how they got interested in Smart. And this is an example of what a listing looks like in the gallery. It can include screenshots or a video so that people can see what it looks like to interact with your app, basic information about who the app is for and how it works, and then some really FHIR-specific kind of stuff, like which EHRs does it work in. And we haven't gotten into this in any detail, but many of the vendors have their own stores or galleries or orchards or exchanges where you can go and see which apps are compatible with a particular vendor product. And so when we list apps in Smart's gallery, we'll link to the underlying vendor stores if that app is listed in those stores. So for example, this is an app that's available in Cerner. You can click through and see the listing in Cerner right alongside. But this knows which versions of FHIR an app is compatible with, has information about licensing, and how to learn more. But the feature that I wanted to show you very quickly was this button at the top called Try App, which is really where the Smart Gallery gets sort of interesting. It's tied into a demonstration EHR with some synthetic data that we make available. And when you launch one of these things, if I can blame either the internet or our server or their server, we'll see. Basically, you have the option to pick a patient record. And then once you've picked it, it launches the app against that synthetic record. And in this case, what you'll see is a medication list. This is the Medication tool. Its job is really translations. So if you've got a patient who speaks who's in your emergency department and they don't speak English, maybe they speak Korean, you can give them a handout in Korean that they can take home with them based on their particular medications and the schedule and the dosage instructions that you've prepared for them. What you'll get is a PDF that you can print out and send along with them when you discharge them from the emergency department, if we can get the internet to cooperate. Take my word for the fact that eventually a PDF is going to pop up in this box. And the words in the PDF will be in the language of our choice. So that's a super quick demo of the Medication tool. And with that, I'm going to pause and turn over to Dan, who can talk about the developer tools that we make available for building an app and getting it supported. Oh, yeah, and I'm going to hand Dan the microphone.
Okay. Okay, can folks hear me? Great. Okay, so Josh talked a little bit about kind of the underlying standards behind SMART. And what I want to talk about a little bit is some of the tools and resources that the SMART team, which is a joint effort, nonprofit effort of Boston Children's Hospital and Harvard Medical School, have put together to make it easy to build and test apps on top of these standards. And so all our resources are available at dev.smarthealthit.org. It links to our Sandbox environments. It links to the EHR vendor Sandbox environments, as well as tutorials and developer libraries. And so I thought to show some of these tools, what I would do is demonstrate how to build a very simple Smart app using the Smart JavaScript library. We also have libraries for other languages, including Swift for iOS and Python, and there are community Smart libraries for Ruby, Java, and .NET. And so as a developer, even though you don't have to necessarily spend a lot of time kind of wrapping these underlying FHIR and OAuth standards, these libraries provide a nice interface for working with that. And so to do this, I've put together an app that shows, that graphs a patient's blood glucose, often used for diabetics. It tracks their A1C values over time. And a lot of EHRs already do this, but what I think, this sort of app could be a starting point for a more complex app that maybe looked at a population or did complex analytics for a patient. So this is actually the first screen. We're going to look at an app that does the EHR flow that Josh mentioned. So the idea here is that the user, probably a clinician, is launching the app from within the EHR. The EHR is calling out to the app, and that's what's happening on this page. So this is when the Smart library gets this notification that the user has launched the app. And so, as Josh mentioned, there's two pieces of information that the app has to give back to the EHR at this point. The first is a client ID, which is a token that the app gets when it registers with the EHR. So as an app developer, you're going to register your app with the EHRs you want to connect to, and you'll get back this client ID. One of the neat things about the Smart test environment is that we don't verify this ID. So whereas in a commercial EHR, you'd want to register for security, in a test environment, that's actually a little cumbersome. You don't necessarily want to have to go back in and re-register your app every time you change something. So we don't verify some of these parameters like client ID. So for the Smart test environment, you can pass in any. The second kind of required parameter is the scopes that Josh mentioned. So these are the particular access that the app wants to get from the EHR. For this sample app, we're going to be graphing some lab results, which are observations. So we have some observation read. These are patient-level scopes, so we're only going to get data on the in-context patient from the EHR. We also request that the EHR provide a patient and that we get patient demographics. Now, there are other parameters you can put here too, like the redirect URL where the server should connect back to your app, but those also have intelligent defaults. And so if you're kind of going along the happy path, then you don't have to put any additional information here. So this is going to redirect back to the EHR, which will then potentially have the user log in, authorize access. Again, if we're launching from an EHR, perhaps the EHR already has the user logged in, and the access may be at the organization level, so it may just transition to the app. And then what's going to happen is this second page is going to load. Here we're providing two functions back to the Smart library, a function to call if we're successfully connected to the EHR and a function to call if we have an error. If we connect to the EHR, I'll talk about the success function first. We're going to issue a query, a FHIR query, using the Smart FHIR library to say I want observations with a particular LOINC code. LOINC codes are lab codes, among other things. And here I'm looking for A1C lab values. Of course, in a production application, you would probably have multiple codes here because sometimes labs can be classified different ways depending on how they're performed. But in this case, we're just using one. I'm looking for the 10 most recent observations sorted by date. And so these are standard FHIR search parameters that are in the FHIR documentation. Once we get values back, then I'm just looping through them here and pulling out the lab value and the date. This, I should mention, this code is all available online. I used a code hosting service called Glitch, so you can actually go on after the talk and create your own copy of it and play with it. So don't worry too much about the exact details. And then I'm passing this data back to a charting library to display it. So now we have this app, right? And it's running on exciting Firefly, which is a automated location on this Glitch service. So it's not hosted at all by the same people as the EHR. But I can go into the Smart App Launcher and test out the app. So the Smart App Launcher is our front end for the Smart Sandbox environment. We have about 1,500 sample patients for both the Release 2 of FHIR and Release 3. Which is about 150,000 FHIR resources, FHIR data models, that you can test your app with. It's a mixture of synthetic data and de-identified data that covers a good number of scenarios. And within this sandbox, you can test different scenarios. So we're going to show the provider launch, which has an option to simulate an EHR frame, which is great for demos. It kind of shows it how it would look to an actual provider inside an EHR. But we could also test the provider standalone launch, or a patient standalone launch, as if a patient or provider were launching an app and connecting to the EHR, in which case the launcher will give you a URL that you would use in your app as the FHIR server. So as I mentioned, we have a lot of sample patients, and so we also provide a patient browsing tool where you can filter the patients to find just the sample that you want to test your app with. So if I were to launch this app without pre-selecting some patients, I would be given a list of the 1,500 patients to pick from. But you can imagine if you're testing your app over and over, you want to be able to have just 1 or 2 patients or maybe 5 patients that really encompass different scenarios. So in this case, since we're testing an app around blood sugar, I could look for pre-diabetics. So if I look for a condition pre-diabetes and do a search, you can also filter on demographic characteristics and comorbid conditions. And assuming the internet's fast, we'll get something here. Let's sort by ID. So I'm going to pick one of the patients. You can actually dig into the patients a little bit and see what data is available for them. So in this case, I want to look at laboratory observations. I'm going to group by name. And I can see that this patient has a set of blood sugars that would be good for demoing this app. So I'm going to select them. I could also just select the next patient. I'm not going to take the time to look through that. So we've now got 2 sample patients specified. We can also specify a provider if we want to test with different providers for single sign-on purposes in this case. I'm not going to focus on that now. You can also request an encounter be passed from the EHR, and we have ways to pre-specify that. In terms of FHIR version, many people build apps now that work with multiple FHIR versions, so you can easily flip between them when you're testing. And one of the features I really like about the app launcher is that all of these settings get baked into the URL. And so you can bookmark it, you can email it to somebody, and they're able to test the exact same scenario with your application that you tested. So I'm going to paste in the URL from this Glitch service for that app we just built. And I'm going to hit launch here. And you can see we're launching inside the simulated EHR frame. It doesn't do anything. It'll show kind of the current patient and provider, but it's a great way to do demos because it really helps people understand kind of where they're, what this app will look like when it's launched within Cerner or Epic or a different EHR. In this case, I'm going to pick one. I've selected these pre-selected these 2 patients who have A1C values, so they're good to test with. So I'm going to pick one of those. And you can see that the app has connected into the EHR back through the FHIR server that was passed to it, pulled out the values, and graphed them using that plotly graph function. And then the one other thing I wanted to show about this EHR is really my favorite feature. So I mentioned that here you pass 2 callbacks to the Smart library. The second one is an error callback. And in this case, all I'm doing is saying an error occurred connecting to the EHR. In a real app, of course, you'd want to provide more detail about the error. But one of the neat things about the Smart App Launcher is that you can simulate errors. So if you want to test how your app reacts to different failure scenarios, you don't have to kind of get very creative and try to recreate those exact scenarios. You can say, I want to see what'll happen if I have an invalid client ID token when I launch my app. So in this case, if we were to launch the same app again, it's going to say an error occurred connecting to the EHR. And so that's kind of some of the neat testing that you can do using the Smart Sandbox. The last point I wanted to make about the Smart Sandbox is that Vlad Ignatov on the Smart team put a tremendous amount of effort into creating a Docker version of this. So if you want to run the entire Sandbox stack, which would be a FHIR server, an auth server, sample data, patient browser, FHIR browser, all on your own system, for example, to work offline or to test with a specific data set, you can now do that, and it installs with one command. It uses a lot of system resources, but it's a really neat way to be able to either to take this online version and run it locally. But the online version is also really good. It's neat when you're testing with colleagues. You can pass around URLs, and they can try different scenarios. So I think we're pretty close on time, so I'm going to kind of end the demo there. I think we have maybe 5 minutes for questions.
What's the workflow that you guys normally have to go through in order to implement another EHR system?
Yeah, so there's the theoretical answer and the practical answer there. I think the theoretical answer is that if you're using Smart, then it's really just registering with that EHR, and you'll be able to launch the app. The practical answer is that the different EHRs support slightly different subsets of FHIR, and so often you'll have to customize the app a little bit to work in different EHRs. Also, some EHRs have not implemented single sign-on yet. So if you want to, for example, pull the provider authentication information into your app, that'll work in some places, and in some places you'll have to kind of drop back to native EHR APIs.
It looked like when you were showing the patient launch context, that was within the context of a single patient. But if you have a scenario where this is patient data being shown to a patient, and you want to be able to select multiple patients, like a patient and their dependents, is there any support for that right now within the Smart on FHIR kind of the communication back and forth, or is there plans for that?
Yeah, right now, the levels on which we do access control are one patient at a time, or the group of patients that a user is authorized to see. And so if we think about some use cases for patient portal-based apps, you might have, for example, a parent who has access to her own record and 2 children's records. So that's a place where an app might ask for user-level scopes inside of the portal to get sort of that cluster of individuals. But when it comes to clinician-facing apps, we've really just done patient and then all the records that a clinician can see.
Yeah, so that's a really good question. So we're really operating this as a listing site, and that's a hard problem. But in general, what we're suggesting is that kind of healthcare institutions use the same procurement process they would use for any app, where they're going to do kind of a security audit, a review. They're going to sign a business associates agreement if it's hosted, a service level agreement, that sort of thing. So we don't really address the legal parts. It's really around the technical side of it. And so you still have to be comfortable with running that app.
And I'll just add, this is something today that the individual vendor stores are doing a fair amount of. It varies from vendor to vendor, but often there's a vendor-led security audit. Sorry, was that a 5-minute left, Mark? Awesome. So yeah, one of the big questions becomes, across vendors, how do we get some common ground and make sure that you as an app developer don't have to go through this each time? Was that 5 minutes left in our session, or our session's over and everybody has 5 minutes to get to their next room? Okay, great.
We're actually earlier than that.
Great. Please.
For items like your web chart, have you had any requests to break and sway it, like to send an image of it back to the EHR from your Smart app?
So I think there are a lot of use cases where even an app that is sort of a read-only or a read-mostly app wants to send some kind of record back to indicate, at a minimum, hey, here's the interaction that a clinician just had with this app, or maybe in more detail to specify what the user saw, what recommendations they were given. Today, the best approach that we have to this is that an app can go back to the EHR and write in a document a note documenting what happened. And this is something that is supported by commercial EHRs in production. It's coarse-grained. It's at the level of, here's a whole document just saying whatever. Over time, I think we'll get into more fine-grained opportunities for writing data back to the EHR. Other questions? In the back, please.
Yeah, I mean, so I think there are some apps in the gallery that work as a SaaS app. I think they're tied to subscriptions. So you can kind of have the service which the user subscribes to, and then the app which they use to access the service, and sell both. And you can use that single sign-on capability to tie the user account in your app, which is maybe the account that's billed, with the account in the EHR that they're connecting from. So I think there are ways to do it. Oh, I see. Yeah. So there's, it's kind of all over the map. So what a lot of app vendors do is they kind of sell a version that the healthcare institution will run behind their firewall, because a lot of healthcare institutions are more comfortable with that. But from a technology perspective, there's no reason that you can't kind of host the app centrally, even have it be multi-tenant, and have the EHRs kind of punch a hole in the firewall to be able to connect to that app.
And I mean, in terms of things like revenue sharing between vendors and apps, this is not something that we try to specify as the smart group. That's a sort of business detail that will vary from EHR vendor to EHR vendor rather than a technology detail. Other questions? All right, well, we are going to be around all week, so please feel free to come and grab me or Dan over the course of the next couple days. Thanks, everyone.